Thank you, John, and thanks everybody for coming. I'm going to talk about mobile SSO today, asking the question, are we there yet? I tried to steal the kind of cloudy theme from the Cloud Identity Summit here, but using my own picture. This is up in one of our offices in Vancouver, beautiful place. So I'm going to have a lot of content today, so I'm going to kind of just get to it. Maybe. There we go. I guess I have to stand here. Okay, so get some of the formalities and introductions out of the way. As John said, I work for Ping, do a lot of things there. I'm not entirely sure what, but I've been around for a long time, so they just kind of let me roam. You might know me as that guy with the camera running around. This is going to kill my timing. Running around taking pictures. The big flashlights are mine, so apologize if I've gotten in your way. Probably in your face with a camera at some point here. And yes, I am that guy. This is from boot camp last year. If anybody's going tomorrow morning, I'll be sure to capture you in all your beautiful glory. Just wanted to say that the slides will be available at my slide share here, and also probably tweet out a link at Twitter. My handle's a little weird. It's 2 underscores, a B, another underscore, and a C. It's hard trying to get a unique handle on with a name like mine. This is my safe harbor slide. A couple of disclaimers. The views are, everything I say in here is my view alone and not necessarily that of my employer, although it should be the view of my employer. It's not necessarily representative of that. Gosh, I'm sorry with my technical glitches here. I also want to say that I'm wholly unqualified to talk about mobile. I primarily do server-side development, and honestly, I don't even do that much of that anymore. So you might be asking yourself this question. So I do know a few people involved in CIS, which helps me get on the stage. And I do use a mobile phone from time to time, although not always that well. I do want to say that sometimes, though, an outsider's perspective kind of brings a unique light on things and can see things that maybe aren't obvious to people that are really close to the problem. Sorry about the timing. There's a couple pictures I've taken over the times of things that just aren't quite right that I thought I'd share. So my premise here is that single sign-on on mobile just isn't quite right. That's not me or my mobile, but another picture I liked. And I'm going to try to demonstrate this by a semi-contrived little story about me and my phone. It's true-ish. It's based on facts that didn't really happen. But it's kind of true. So the other thing about this story is I'm very, very busy and very important. And you can see that from my opulent travel budget. Yes, that is a motel, and yes, that is a scooter. That's how I travel. I'm sorry. So I'm actually one of those Luddites, old school people that actually prefer to do real work on my computer. But sometimes I'm on the road, and I'm forced to actually try to get work done on my phone. I was in Dallas recently, and that was one of my as you can see, I use a lot of excuses to throw in my pictures up here, but I was actually in Dallas trying to get something done on my phone. I'm going to try to walk through that here, maybe. So I'm out there. I'm trying to join a meeting while I'm on the road. I want to just get on a meeting. I've scheduled I know it's on there. So I'm going to pull up WebEx, hit the WebEx icon on my phone. I'm presented with this dialog. I go ahead and choose to sign in. WebEx pops up this thing asking me what my vanity URL for WebEx is. pingidentity.webex.com, and that kind of lets them know what my tenant identifier is for Ping's tenant of WebEx. Put that in. It pops me off, picks up the system browser, pops me off to do SSO with my corporate IDP, Ping's IDP. These are my 80 credentials on site at Ping, redirecting me, doing SAML. After I enter my username and password, I get prompted for Ping ID second factor authentication. This is something that we've rolled out in the last year or so. We use it internally. It's not particularly important here, but it's nice to see that WebEx can basically support whatever kind of authentication we're doing in our enterprise, be it username and password alone, be it username and password with second factor auth, be it federated SSO. They can do all that stuff that we've already invested in via Web SSO here. It kicks me off, sends a push notification to my phone. I push up this little thing, it's waiting, it's authenticating, I'm good. After that's authenticated, it flips back to the web browser context, that finishes off, and it sends me back to the WebEx application signing me in as me based off of my corporate SSO. I get into WebEx, it lists up my meetings. Here's one, customers want it all. I'm sure they do, but this isn't actually the meeting I was looking for. Interestingly enough, we use two different collaboration meeting tools at Ping, so I apparently checked the wrong one. I'm gonna go into Biba, which is another one, try to find my meeting. Same kind of flow, I sign in, click sign in here, touch sign in. In this case, I've given it my email, but I also have an option to sign in with Ping 1 versus username and password. This is kind of analogous to what Ian was saying this morning. We want to push vendors and others in the direction of providing federated SSO. Biba's nicely doing that with us. So I click on sign in with Ping 1. This is basically saying I want to do a federated SSO here. It's going to ask me my domain. Same thing. It's basically doing a discovery step at this point. It wants to know what organization are you associated with so I can send you to the right corporate IDP to sign you on. Ping identity here. I've entered this previously, so it pops up. It kind of remembers it for me, but it gives me the chance to change it or modify it, just kind of remind me what's going on. I hit OK here. It pops up the system browser as well and sends me back to my corporate IDP. You can see this flickering, but I don't have to enter anything. It picks up the callback. Biba picks up the callback from that and pops right back into the app, signs me on. I saw a few flickers there, but it was totally seamless, and I didn't have to do any typing on my little phone. So it's a nice experience for me. I've already signed in. I don't have to sign in again. It loads my meetings, and there's the meeting I was looking for. It's a joke. It's funny. Whatever. I'm a little frustrated by this experience. Actually, I'm sorry. How do I think here? I'm not frustrated so far, but I'm on the road. I like to drink coffee, a lot of coffee. I need to go in and expense the coffee I bought before this meeting. We use Concur, a SaaS app for travel and expense reporting. So I pull that up maybe. It loads directly into Concur. Sometime earlier, I did the same kind of discovery step and entered my, my work email here that basically figures out what tenant I am. Concur kind of hides that. Once you've entered it, it doesn't enter it again. So every time I pop up in the app, it kind of does the discovery automatically. It loads, and then it redirects me to my corporate identity provider. But even though I just signed on a few minutes ago, it's asking me to sign on again. A little frustrated by this, but it's there. Notice also that it's happening inside of their own app. They're using a web view here. So even though it's using a web browser, it's going back to my corporate IDP. There's no real visual cue or any indication that I'm actually at my company site. So I guess I trust Concur. I kind of don't have a choice but to trust Concur because I need that $2.50 coffee to be expensed. Like, I couldn't go without that. But there's a possibility that I'm being phished here. There just is. There's no way for me to identify otherwise. I'm just kind of running on blind faith, which as a security professional, I don't really like that. Anyway, I type my password. Oh my God, that's my best joke. I'm sorry. Type my password. Thank you for being there with me. And I typed it wrong, because it's hard on the little keyboard. And then I feel like this. It's a real place, by the way. Try it again. Maybe. And it pops back in, loads up my Concur, gets it done. So there was a similar sign-on experience. I used my corporate credentials, which is nice. At least I don't have a new password for Concur. But even though I've just signed in a few minutes ago, I had to sign in again. And that's sort of frustrating. I actually went through this one time when I was having some other connectivity problems and couldn't get in on the mobile app. And so I had to do it on my laptop. Took a picture of myself with my $2.50 double espresso on my laptop screen and submitted that through Concur on my laptop. I don't think the auditor probably appreciated the irony that I was trying to project there, but it made me feel better. It's a bad picture too, but that's me staring behind the receipt. Next thing I want to do is load up our little chiclet page, our Ping 1 doc, but it's sort of various web apps mobile here. So I start to type Ping 1 in my mobile browser on my phone. I don't know why Pizza Hut comes up. I don't think it's a personalized recommendation, but I don't know. Type in Ping 1, it's loading, and it loads this little chiclet page. It's nice. So really what I wanted to do here was check Ultimate Software, which is our payroll and HR provider. I want to see how much money I make, because this is kind of frustrating, and I want to remind myself why I go through all this. So I click on that. I'm redirected to Ultimate. seamlessly logged in. Again, because I'm using the web browser here, and I'd previously authenticated with the web browser, there's a shared context as a cookie, and I get seamless SSO right into our HR provider. Turns out I don't actually make very much money. I just had to remind myself. So I go back here, and I want to log into our healthcare provider, check and see what kind of benefits I have for therapy, basically, because I need some consultation about this. Click on United Health, SSO directly in United Health. So I've accessed, I don't know, 5 or 6 applications here. Almost all of them I got legitimate, seamless single sign-on into. One of them I didn't. So I'm not very good at transitions. Sometimes I just throw random stuff in there to kind of bridge between the two. This was actually at CIS last year. I don't know if anybody stayed for the Volcano Warrior. Sorry again about this. But what I want to do, maybe, is talk a little bit sort of what's happening behind the scenes with the experience I just went through. Either what is happening or really what should be happening to kind of improve the experience. And basically what's happening is a combination of web single sign-on and either OAuth 2 or things that are very similar to OAuth 2. Not all the apps I showed before were actually doing OAuth 2, but I'm going to present it as sort of the archetypical case of what apps maybe should be doing. So real quickly, I want to cover web single sign-on. Most of you already probably know this, but you have some identity provider. In this case, it was Ping Identity, providing my identity out via web SSO to various service providers, all the various different apps I was there. Typically, this is with OpenID Connect or SAML 2, more SAML 2, but trending towards OpenID Connect. You also get things like older versions of SAML, OpenID, older, WS Federation. Sometimes you get proprietary things like Facebook Connect or whatever it is that Twitter does, or various non-standard ways. They're all kind of similar, but some sort of web-based single sign-on. And then OAuth 2, kind of in one slide, real quickly. Oh, my animations are terrible, I apologize. You have a client, you have an authorization server and a resource server. In the case that we're going to talk about here, generally the client is going to be the native application on the phone, and both its authorization server and its resource server are that client's sort of SaaS backend, whatever the backend for that service is. And typically these days you have a front end, you have your native app, and you have some one-to-one correlation with a backend service associated with that. The resource server is sort of the APIs that the app's going to be calling, and the authorization server is the thing that's capable of issuing tokens that the resource server can consume, authenticating the user and getting the user's approval. A few other kind of terms in the OAuth world. Access tokens are the tokens that are issued by the authorization server, and the client presents those to the resource server, the API, to get access to them. Refresh tokens are sometimes issued in correlation with an access token, and it lets a client get a new access token when the previous one's expired without putting the user through the whole dance of authentication and approval. A scope is a set of permissions that can be requested in the initial request that allow the app to ask for only a specific set of permissions. So it's not asking for the kings to the kingdom, it's asking for scopes specific to what it needs to do to its job. So even if there's some compromise of the app, hopefully we don't have that, but even if there is, what's compromised is limited in terms of the impact of what's there based on the scopes that are requested. The authorization endpoint is where you actually send the end user in the browser to do the authentication and authorization step. And then the token endpoint is where the client interacts directly with the authorization server backend to exchange tokens and do other things. And the authorization code is this concept that's sort of like a little handle to the authorization. So after you go through, do the approval, the authentication, the authorization server sends back an authorization code to the client. The client turns around and exchanges that code for the actual tokens representing that authentication and authorization, mostly authorization. Bear with me, thank you. So when you put web SSO together with OAuth 2, you get a reasonably nice mobile SSO experience. I'm going to go through kind of the various steps outlined in this diagram. On the top, though, you have your kind of your home backend service for whatever your app is. You have your device down below with a native app running on the device and interacting with the system browser, the default system browser on the device, on the mobile phone itself. And then somewhere else, you have some enterprise IDP. In our case, it was Ping in the example I showed before. But a lot of corporations now have their own enterprise IDP. Or even potentially, in some cases, this might be a social identity provider or some web-based SSO provider. The first thing that happens is when the app realizes that the user needs access to some API on the back end, realizes they need a token, access to some protected resource. And really, in the app world, this is kind of the not logged in state. It makes an authorization request, launching the system browser to the authorization endpoint on the authorization server at the backend home service. And it looks something like this down here, with a few things identifying the client, the scopes that you're interested in. This little example is basically like a status updater. So the scope we're asking for is status update. An IDP, we'll get to that in a second. Another thing you can do at this stage is basically IDP discovery. Figuring out through prompting and remembering in the app itself who the home identity provider for this user is. It's often done with either like a vanity URL or a corporate email there's a call back to the back end of this provider to figure out sort of what tenant that individual belongs to and where to send them for SSO. It's nice to do this in the app itself. I want to take a quick note to talk about Apple here. This picture is just sort of a reminder to me. I don't know if anybody saw somebody vandalized Google Maps and did this little piece, but it's not really meant to be a knock on Apple, but they are doing some things that are sort of problematic for this flow. So Apple's been rejecting applications that launch the system web browser for reasons I'm not entirely clear on. But one way I understand, I've been told to work around this, is to do the pre-discovery step in app like this and have different kind of users and different kind of tenants in your backend. So that if they're a federated user, you do the launch system browser and do the federated SSO like we've seen before. Or if they're just sort of a local normal account user, you can prompt them directly for username and password and authenticate them within the app. There's a lot of reasons you don't want to do that in general, but it's an opportunity to support two different kind of customer bases and work around the restrictions of Apple's App Store, and by providing them with test users that are sort of native to your backend application so they can authenticate directly through the app itself, whereas in supporting real sort of enterprise customers, you can do this discovery step and do SSO. Another important thing, and Patrick mentioned this morning, is Pixie. Someone came up with the pronunciation Pixie, so I wanted to throw a Pixie stick up here. But this is a way to bind the initial request with the callback. So the application, when it launches the authorization request, it includes this random code challenge on it. And when it comes back later, when it gets the callback with the authorization code that I mentioned, it's going to have to present the same value. And what this does is protect against an application coming along and registering itself to intercept the callback and try to steal the tokens post-authentication and approval. This Pixie standard allows you to use, basically just add two new URL parameters, both to the initial request and to the token request later on, that bind those two things together and ensure that the app that's asking for the tokens later is the same app that actually asked for the authorization in the first place. It binds the code exchange to the authorization request. It's really just one parameter. It's an RFC in waiting. John will tell you that it's sort of in the last throes of fighting with the powers that be at the IETF, and hopefully it'll be a full RFC maybe sometime later this summer. The next step is you authenticate and approve. So you get, within the launched web browser, you get redirected back to your identity provider. In this case, it was Ping, enter my password, do my second factor. And then in this case, the service provider, that's the SaaS that's providing the app becomes the traditional SSO SP. After you receive the authentication response, probably SAML, but maybe something else, the SP now acting as the authorization server also should request user approval for the transaction. And it's important not to skip this step, even though all the examples I showed previously did. There's some things, some protections you get by actually asking the user to confirm what they're doing here. The next thing you do is handle the callback. So once that's done, the authorization server sends a redirect, a typical 302 HTTP redirect, but it does it using a custom URI scheme in that URL. And that URI is registered against your application. So the OS sees the redirect and via the registration picks up that app and invokes your app with that URI. And what's being recommended right now is that you use a reverse domain name as the redirect URI scheme. So instead of just doing like my app, my app : whatever, you want to do something like this, org example my app. And what this is it's resistant to accidental collisions. So in the OS, if you have multiple things registered against the same scheme, some will ask the user which to do, some will just pick one. But if you use a qualified namespace, you're protected against sort of accidental collisions on the callback. And it also gives you some protection against sort of malicious registrations of the same scheme. Not directly at runtime, but if you use a domain which you own and can prove ownership of, if there's somebody else trying to sort of spoof your callback by putting app stores in the App Store that steal your callbacks, you have some recourse by showing proof of domain or proof of ownership of the domain to hopefully sort of lobby to get those apps removed. The actual response looks like this. It's a regular HTTP 302 redirect, and the location then is to this custom scheme with a host that doesn't really matter in this case, and then the code, the authorization code on the end of this. And this is what allows the app to pick up the results of that authorization. The next thing you do is the app trades that code for the actual tokens, making a call to the token endpoint at the AS. It's just a post, has some stuff. It's client ID, the grant type of the authorization code, the code itself. So it picked up the code from the callback. Now it's going to the server to exchange that code for the actual tokens. And then Pixie again. This is where the app presents the same value that it had previously sent on the authorization request. It sends it here, and this allows the server to associate that to and make sure it's the same app and doesn't give out the tokens to some rogue app that may have picked up the callback. The response is just the tokens. It's some JSON with the actual tokens embedded in it. And now the app can use these tokens to actually make API calls at the server. So it makes a post here to update the status. And really all that's in here is the authorization header, bearer, and the actual access token from the previous slide. And this is how it's authorized to access these APIs. So if everything goes well, you just sort of rinse and repeat and do the same thing. There should be an HTTP 200 in here. If it's not, you'll get a 401. And basically, this just tells the app to go through the same steps again. If you have a refresh token, get a new access token with it. If you don't, put the user through the same authentication and authorization flow to get a new token. So some people like to use a web view to do this. And basically, a web view is everything we saw before, but just embedding the web view inside of the application and launching it within the context of that. This is what you saw Concur do earlier in my example. It's nice from some people's user experience, but it has some serious problems. One is it has some usability issues. The first one is there's no shared context, no shared cookie between different events, and that requires sign-in, multiple sign-ins for each invocation, even when SSO is otherwise possible. And this is what we saw with Concur. Even though I'd previously authenticated, I already had an established session context in my browser. I was forced to log in again because Concur chose to use an embedded web view for this flow. So there was no cookies, there was nothing shared at that point, and required me to sign on again. So it's sort of frustrating from the end user experience. It also has some pretty serious security issues. One is that the web view typically isn't sandboxed from the invoking application. So if Concur had wanted to sniff my credentials as I was going through there, they're capable of it. If wanted to steal my session cookie after the fact, they're capable of doing that. So it's sort of problematic. It also requires or even encourages users to enter credentials without the address bar that you'd normally see in a web browser, which means that there's no visual cues of whether this is a secure connection or not. It really promotes the possibility of phishing. And it's missing some features. Some web views are unable to access client certificates. So if you're doing mutual TLS to authenticate your users, it just doesn't work in a web view. And it's generally unable to use things like password managers, which a lot of people come to rely on. If you're doing this stuff in a web view, it's not going to work. So you might ask yourself, well, where does OpenID Connect fit in all this? It's a simple identity layer on top of OAuth 2 that does SSO. Basically, it adds an ID token for the SSO piece on top of all the other tokens we just saw, and a bunch of other stuff too. I'm running out of time, sorry. So where does it fit? It's really great for the web SSO part of this. Between your sort of SaaS backend and the IDP, it's great for web SSO. And it can also be layered on top of the OAuth portions that we just saw to give some additional identity and context information in a standards way, but it's not strictly necessary. It's just sort of a nice layer. So you might ask yourself then, what about NAAPS? It's intended to be a profile of OpenID Connect to enable SSO model for native applications installed on a mobile device. Same thing we were talking about here, but it's a sort of a different way of looking at it. It provides this thing called a token agent, which sort of takes the place of the system browser as the shared context for authentication. It's great. It's just not real. It's not real yet anyway. And some examples of this are, if you go to Google it, you'll get these search results. And the NAAPS we're talking about is not the National Association of Professional Pet Sitters. It's this one down here, Native Applications Working Group and OpenID Foundation. If you go to the website there, we have this link here that says the link below will eventually be to the HTML version of the actual standards. And it's been saying eventually for a long time now. It hasn't become real yet. There's the actual source behind it. If you know where to look, you can see where the standards are actually checked in. There's a bunch of different drafts here. It's hard to tell which one is real. John actually just checked in new versions of a new way of doing things in the last couple of weeks that even I haven't read yet. So there's some progress there, but it's slow. It's slow to develop. And even once they become standardized, it'll take time to actually roll out adoption. As we've seen with a lot of different specs, it's not immediate. It takes time to complete a standard, and it takes time to adopt the standard. And NAAPS just isn't there yet. Another example of that is the mailing list. I think the last actual activity on the mailing list was back in March. One nice thing about NAAPS, though, is where the recent thinking about how the flows will work is not totally incompatible with the way that what I just described works here. So if you're developing a native application, if you kind of do two things, you make the call out, you pick up the call back, you won't have a huge port to do the same thing if and when you decide to adopt NAAPS, so it won't be a huge change. If you're interested in learning more about NAAPS, I think Sheesh later in this period is going to talk about more. So will Adam talk about NAAPS-related things. John will be talking about it later today, and I think Andy will touch on it in the same track. So there's more to learn about NAAPS. Anyway, in the near term, though, while we're waiting on NAAPS, here's sort of a recap of the sort of recommendations I have. One is use OAuth 2 and Pixie, maybe OpenID Connect if you want to layer that on. Use WebSSO for the actual authentication piece. Prompt for user consent every time. Please, please, please use the system web browser so you have that shared context. And use a reversed internet domain name in the custom scheme for the callback URI to protect you against various things. And with that, I'm over time. Thank you, and I'm out of here.
Thank you, Brian.